Okay. Okay.
Yes, sir, yes.
Yeah. So I think let us just wait for some time.
Yes, yes, sure, sir, sure.
Okay. Okay.
Yeah.
So by the way, where are you at this moment? Which place?
Sir, I'm in Mumbai right now.
Okay. Okay.
Yeah, I was there in Punjab in this summer. I was going to meet you actually, but yeah, it
Yeah.
didn't
So next time,
happen.
yeah, next time,
Yeah.
please meet me. Right. Okay.
Yes, yes, sure, sir, sure.
Okay. Okay.
Yes.
Yeah. Thank you. So with Professor Sudarshan, we usually talk about you. So anyway,
Yeah. Ashu sir told me that you are in the IIT Ropar campus itself. So I was
yes.
going to meet you, but yeah, at that time, I'll for sure meet you next time.
Sure. Sure. Okay. Okay. So let us
Yes,
just wait and then we will see. Okay. Thank you.
yes, sir. Yeah.
Yeah, hello. So I think the students are not joining, I think, right?
Yes,
Yeah,
sir. I guess
yeah,
the
maybe.
issue is with the issue is with the timing. Maybe people
Yeah,
are having their offline colleges or something
yeah.
like that.
But anyway, I think that we have weekly live sessions already, right?
Yeah, yeah.
And I
PMRF
have
sessions
also,
are being conducted. Yes.
yes, and I also saw that their problem or their problems also have been solved, right? So I was just seeing
Yeah,
it. That there are some problems, right? At week 9 assignment, problem 6. So I was seeing that some
yeah,
of
yeah.
our TAs are responding to them.
Yes, sir. Yes.
Yeah, so this is also what.
On the discussion forum, I
Yeah,
am answering the questions, and the PMRF sessions there are special students
yeah.
assigned for that. So yeah,
So this is also the reason. They are anyway they
yeah,
are getting the answer. So why for
exactly. Yeah,
this?
yeah,
But
yeah,
anyway, I just wanted to tell you that there are some.
yeah,
So you know that R combinations with unlimited repetitions. You know that, right? The
yeah, yeah,
concept. Yeah. So
yeah,
I think please make sure that there are some problems for that as well. Because I think next month we have exams, right?
yeah, yeah, yeah.
Yeah. So I want
On the
let me just tell you. Yeah, what I want.
yes, okay.
I will just share it for you only. Because anyway there are no students here. I just
Sir,
wanted to let you
I guess there
know.
is one student.
Yeah. Hello. Stuti. Huh?
Yeah,
Yeah, hello. Yeah, anyway, we are just discussing
Hello,
about
sir.
some. Yeah, hello. So how are you?
Yes, sir, I'm good.
Yeah, and how is this course going on? Discrete mathematics. Are you enjoying first of all?
Yes, sir.
Okay. If you have any question, just let us know. If you have any comments or feedback.
Okay, sir. Yes.
Okay. Yeah. In the meantime, let us, Ashik. I just wanted to request you.
yes, sir.
Yeah, maybe I'm just sharing a screen if you can see it. Is it visible?
Yes, sir. It is.
Yeah, so I just wanted to make sure anyway we can meet offline also, but this is the time. So I want you
Yeah,
1 minute, right? I think there is some problem. So R combinations, right, with
yeah.
unlimited repetitions. So
Mm,
that is, you have suppose you have
yeah.
n elements, right, and you can repeat them unlimited times. You understand?
Yes, sir. Yes, yes, sir.
Yeah.
So, so
And
this is
now
the
from this you want R combination. Yes, you want R combinations. Such topic
right.
I think you should maybe if you can give some assignments related to that.
Okay, okay. So in the discussion forum, maybe I can give these questions as daily challenge. I usually give a daily challenge question, so maybe I
Okay.
can add it there. As of
Yes,
now,
yes.
students
Very
are
nice.
active on forum pretty much.
Very nice.
So,
Yeah. So
so,
I think you can have a this the answer is very simple, right? You know that.
yeah,
I
yeah,
think this
yeah,
is nothing but C. So I think n minus one plus r plus r. I think this is the answer.
yeah, yeah, yeah.
And
So, sir,
yeah.
this topic has been covered in the videos as well, and so
Okay. Very
people may
nice.
be knowing the uh, solution for this as well. So
Okay. Very
we
nice.
can give the
Yeah.
question.
Very
Yeah,
nice.
I'll do
So
the needs for.
yeah, this is only for our upcoming exam, right? They have
Yeah,
to
yeah,
appear in the exam October, right? Secondly,
right,
this
right.
binomial coefficient questions you have to just brush up. So you know that
Okay.
Pascal's triangle, right?
Yes,
There
yes,
are
yes.
some. Right? So for example, uh, you anyway, this is in the video.
Okay.
So suppose you want this, right? Without
Yes.
limitation, C n to the r. So how you can
Yeah,
do it? You fix a person first, right? So
yeah,
either it is present or it is not present. Right? So suppose this person is not present, right? So this is how you will pick. Suppose
Exactly.
this person is present, right? So this is what you got it, right?
Yes, sir. Yes.
Yeah. So questions related to this, and there are so many other in Pascal's triangle. This is only to make them. So anyway, exams are coming, right? October
Yeah.
28th, I think the exam is there.
28 and 29. So they'll get a brief about what would be asked in the exam.
Yeah.
So that is
Okay.
why.
Okay.
Sure,
Okay.
sure.
Okay. So anyway, we will meet after some time as well, and we will discuss
Yeah.
it more. So any other students are here?
No.
Or?
So they also left actually. So yeah.
Okay. Okay. So anyway, let us just stop here. Or what your suggestion is? Should we continue or?
Should we wait for 5 minutes
Okay.
until
Sure.
2:20?
Sure. I'm here only.
Yes.
Okay. Okay.
Yeah.
Sure. Thank you.
So, sir, currently on what topic are you working in the research?
So, so in research area, I am working on proof complexity.
Okay.
So what is proof? Yeah, proof complexity. Yeah, proof complexity is a very important topic. So look, there are theorems and we are proving those theorems, right? That's why we are discussing discrete mathematics also.
Exactly.
So
Yeah.
there are theorems and we wanted to prove that theorem, but can we prove it automatically? Get a program such that you will give a theorem to that program in some encoding, right? In some proper encoding that the
Yeah.
algorithm can understand. And now he has to prove it. First question. Second question is, suppose I will give a proof to a algorithm, right? And I will say that, can you check it? Can you verify it? So this is all automated theorem proving.
Right. So, sir, for this, we need to train a model and then need to test the remaining theorems. Is it like that, or we give a set of rules and algorithm and then it does? What is
Yes,
the approach?
set of rules and algorithm. This is like a
Okay.
proof system. In mathematics,
Right.
also in geometry, also this is what, right? We have some axioms and we have some inference rules, and slowly we go and proceed, right?
Right. So
So the
training
same
and
thing.
testing won't work here actually because the
No. It
system
is not.
cannot think. Yeah.
It is not that it will not work. It is an open problem. Can you use machine
Okay.
learning for this? Right? People are
Acha.
working in
Nice.
this as well, but it will take some time. So
Hmm.
the current
True.
approach is this inference system.
Hmm.
You assume some axioms, you
Yeah.
have some fixed inference rule, and can you derive it, search it?
True.
You understand? So this is what it had happened.
Yeah.
And I think, have you heard about set solvers?
Uh,
Set solvers. So
no, sir.
look, Ashik,
No.
yeah. So there are some satisfiability problem. Very simple problem. We'll have some n
Satisfiability
variables.
problems.
Yeah. So I
Yeah.
have some n variables, Boolean variables.
Huh.
They're connected
Huh.
with and or not. We have a
Yeah.
statement, and I'm asking whether this is satisfiable or not.
Oh,
So
right.
this is an
So
NP
this is
complete
a
problem.
NP complete problem.
NP complete
Yes.
problem. This is NP complete problem. But still, there are so many problems that you can encode like this. So
Right.
practical advanced. And what is NP complete? NP complete means there are some hard instances, right? It's not that everywhere
Yes.
it is
Yes.
hard. So
Right.
set solvers are an algorithm which solve this problem.
Okay. So
So give me
actually,
any set.
solving this satisfiability problem might help us in solving many other application-based problems as well,
Yes.
like
Yes.
Hamiltonian and all. Sir, a basic doubt I had. We say a graph is
Hmm.
Hamiltonian if we
Yes.
connect all the edges and if there is a cycle in it, if there is a Hamiltonian
Yes.
cycle. So now this we according to the Dirac's theorem, we say that if the number of every nodes is greater than n by 2, then
Yes.
the graph is complete, rather connected, and this imbibes the terminology of the graph being Hamiltonian as well. So we say
Yes.
this thing. So this is
Very
a
nice.
sufficient condition,
Yes.
but still we don't know the structure of a Hamiltonian graph. As in, this is also NP hard, or I guess NP complete
This is
problem.
NP complete.
In NP complete, yeah. So there's no sufficient condition as such, we know, right? As of now, we don't
Yes.
know.
Sufficient and necessary.
So, but
Sufficient
we know the
have.
necessary part. We know the necessary part.
Yes.
So we can conclude
Yes.
that this for every graph which has every node degree greater than n by 2, we can conclude safely that it is a Hamiltonian. But there
Yes.
is no
Yes.
lower bound as such, we can say. And that lower bound as in the sufficiency condition we don't have.
So,
है ना?
yeah. Yes. Yes.
Sure.
And people have tried it, but now you know that this is NP complete. So if you have did this, so it is not you under Conics theorem. Have you heard about Conics theorem, right?
Yes, sir. Yes.
And there are certain problems on matching. They
Yeah.
are Hall's theorem, Hall's matching theorem, right? They are if and only if conditions.
Yeah.
That theorem. Have you heard about that theorem? I have a graph and I wanted to say whether this is a one factor or not. What is a one factor? Have you heard about that?
No,
I'm
sir.
just saying that there are problems for which we have if and only if conditions. You can easily go and check that, and you know that whether that graph has that property or not. For Hamiltonian, we don't have such a thing. Therefore, this is NP complete.
Right.
You can have a quick check whether two graphs are isomorphic or not. There are some quick check. If their number of vertices are different, definitely they are not isomorphic.
Right.
If the number of edges are different, definitely they are not isomorphic, right? But if and if condition, if and only condition we don't have, or even isomorphic, and we even do not know whether this is NP complete or not.
Exactly.
We don't
So
know
for
whether
small
isomorphic
graphs,
or not.
visually we can say for isomorphic, I mean small graphs we can say they are isomorphic or not. But for huge graphs, it becomes a tedious task too.
Tedious task. Even proving lower bound, even proving that it is NP complete. And graph theory is full of problems only. Graph theory.
Yes, sir. No, it is really interesting. And its applications are endless, sir. A metro problem, salary problem. There are, it is a really interesting topic.
So in IT Roper, usually, last 3 times I have taken graph theory courses, and the response was huge. Yes. So they really, this is interesting, right? It is not like you have to do integration and all those things.
Exactly.
You have vertices and edges. That's it. I even do not go to only simple graphs we study. That's it. I never go to multi-graph, hypergraphs, and only simple graphs.
They all are starting from the undirected graph itself. So we need not complicate things. Simple things are more easy to get on the mind.
Yeah, and even simple thing you if you have dare, you just solve this problem if you want. Right? Simple graph, there are so many open problems that people cannot. If I will draw some graph randomly, people will not even look at whether this is planar or non-planar. After some point of time, even simple graph, you cannot identify that whether this is planar or non-planar graph. So for that you have to work it out. Whether there's a minor thing is there, right? Minor graphs. Have you heard about Ashik? Minor graph. So you have to find out K3 or K5. Yeah. So there are some things.
K3
so
and
a graph
we have
is
to find
non-planar. Yeah. K5 or K3 as a minor.
Okay.
This is
I'll note down all the points and I'll read all this.
Yes.
Yeah.
So a graph is non-planar if and only if it has a K5 or K3 as a minor. That's a very, very nice proof it has.
Right.
I have some videos also. If you are really interested, I can share you my videos.
Sure.
I have videos.
If you send it on the mail, I'll watch it for sure.
So you just write a mail. I have a drive, Google Drive. I will share that with you.
Okay, sure.
Okay. So what are you interested? Let us discuss. What are you doing in Mumbai?
Currently, sir, I'm doing the IIT Madras BS degree, the data science one. Also, I'm doing my engineering in KJ in Mumbai itself. So it is my last year here. I'm not interested in my engineering at all. That is electronics engineering. My interest is in computing, mathematics, and data sciences parts, the machine learning and all. So I'm working on these stuff right now. I completed my machine learning courses. I did a good amount of maths, but practice is required for maths actually. So it is not like we can say that I've completed my maths. But
so your future plan is what? You are interested in academia or
sir. I am interested in doing PhD.
Okay.
for sure. So that is why I was planning that. And now there is a system of direct PhD as well, right? Just after the BTech, we can enter the
Yes.
PhD. We need
Yes.
not do the master's 2 years thing if we want to save our time. So I'm thinking on this, or and yeah, actually, time will tell. My plannings are in this fashion as of now. I want to do a
Yeah.
PhD immediately after my BS and BTech, but yeah, for sure, I'll think on this
Okay.
one.
All the best. IT Roper is one option for you.
Yes,
By
yes,
the
sir.
way.
Yeah, exactly.
Okay.
I visited Rupert 3 times actually. So I mean, for
Okay.
projects and all. First time I was there for internship, and next 2 time I was
Okay.
working with Ashu sir on the
Okay.
teaching and learning papers. So yeah, I have
Okay.
a good understanding of how the system works there. So there's a, I mean,
Okay.
if I came there physically, that is why I got to know how IITs work actually. So that is the
Okay.
thing. We need to be present at sometimes. Yeah.
Yeah. So PhD admission, you have to apply, and there will be some
Yeah.
interview, and all those things will be there as per other
Yeah.
IITs. That is not
Yeah.
a
We
problem.
have
But
to
if
give gate. We have to keep a CGP of
yes,
around greater than 8 and all. There are
yeah, for direct,
yeah, for direct PhD.
for direct, yes. But anyway, you are planning to give gate also, right?
Yeah. I'll give the gate in data science from this year, 2024.
Yes.
Gate in data science has started,
Data
so I'll give that.
started.
Yeah.
Okay. Very nice.
So
So I think
statistics, hypothesis testing, and all
yes.
these all sort of topic we did in our BS degree. So
Okay.
and the uh, graph theory part is extensively done actually in the BS, because in machine learning we use graphs. BFS, DFS
Yeah.
are the common ones, but we also use many tree algorithms. So it is very interesting.
Okay. And how is the experience of that BS from IT
So
Madras?
it is
That
actually it is the best course. I mean, best atmosphere for learning. We are not bound
okay.
to physically be present anywhere and all. Apart from the exams, we give exams physically on the exam centers in every month. So that is the
So
thing.
in Mumbai also they are
Yeah.
exams. Okay.
Yes.
Okay.
When I was in Punjab, I used to go to Chandigarh for the exams, and in Mumbai
Okay.
we go to the physical centers as well. So
Okay.
the academics is very well prepared. I mean, yeah, of course there are issues in some of the courses, but they have a proper TA system. What we follow here on the
What
discussion forum, we answer. So
yes.
that is the thing, and every week there are around 4 hours lecture for every single course. So that also
Okay.
clears our doubts, and the portal is well defined. There are many questions to solve actually. So
Okay.
yeah, the degree is really well planned.
Okay. 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 So all the best to you. Whenever you are in Dopa, let us meet us. Right.
Sure,
And
sure,
I
sure.
already told you that here you just like combinatoric, binomial coefficients, all this thing topic, you just give some problems so that
Yeah,
they will be
yeah,
prepared for the final exams. And
yeah.
anyway, we will
Maybe
just
I'll
we'll do in that.
maybe
Yeah.
I'll create a mock test, something like that, or I'll give in the daily challenge part itself, and the people
Yes.
will know what should be the
Okay.
expectations.
Okay.
Yeah.
Okay,
So
Ashik, then I think
we can
it's
leave, yeah, sir.
already
Now,
we can
no
leave,
issue.
right?
Yeah,
Okay,
yeah,
okay,
yeah.
okay. Thank you,
Thank you
thank you.
so much, sir.
Bye,
It
bye,
was
bye.
nice talking
Yeah,
to you. Yeah,
yeah, yeah.
yeah.
Bye, bye, bye.
Namaste, sir. Yeah.